Right, good morning, everyone, and welcome to the VRT 600 webinar over the economic analysis of VRT removal. In this webinar that should take about an hour long, what we're going to do is take a look at a Wellsite, take a look at the advantages of having your VRT, and then how you could use Promax to determine whether or not you would still want to use a VRT, depending on the declining flow rate from your wellhead. So this is going to be our Wellsite, and on this first flow sheet, we can see a Wellsite with a VRT, but we're going to take a look at one without a VRT first. And for those of you that may be unfamiliar with Promax, this is what a Promax flow sheet is going to look like. It's going to look pretty similar to Visio if you've used that before. You're going to have a few buttons in the top that are going to give you all of your functionality. You're going to have your shapes over on the left-hand side of the screen, and in the center, you're going to see the actual flow sheet with all the information entered into it. Whenever you start a simulation, you have to define the inlet stream here, and the inlet stream is normally defined with 4 different degrees of freedom. That is a temperature input, a pressure input, some type of flow rate, as well as a composition. So when I double click on my stream 1, this is going to be my well stream fluid, and it's going to have 3 separate phases. We have a vapor phase, a light liquid phase, which is going to be our hydrocarbon liquids, and a heavy liquid phase, which is going to be water. We're treating it as if it's 90 degrees Fahrenheit at 1,000 pounds gauge with a mass flow rate of 34,000 pounds per hour initially. And in the composition, we just have a typical composition for a hydrocarbon stream that's been saturated with water, as well as containing some heavy oils. So this gas is going to go through a choke valve before it gets dropped off into a high pressure separator, which is going to remove the vapor in the top. It's going to remove the hydrocarbon liquid in the middle here, and the water is going to go through the bottom. So that's our first separator. Then in the next separator is actually a heat treater, or a heater treater. So we have some desired outlet temperature as well as a desired pressure. And we're going to be separating vapors off the heater treater as well, some hydrocarbon liquids, and water if there is any extra carried over in our original hydrocarbon liquid stream. And then finally, our hydrocarbon liquid stream gets to an atmospheric hydrocarbon tank where it would be stored. So this tank is going to be at atmospheric pressure, so that is the final pressure of the system, and any resulting vapors that come off of that tank would be treated as emissions. So as we can see here, we have a standard vapor volumetric flow of about 170,000 standard cubic feet per day. And those would all just be counted as general emissions in this case, or as your flashing emissions. And that could be a problem. So we'd want to be able to address that. And that is actually why we would like to use a VRT, or one of the purposes of using a VRT. Is to reduce these emissions. And if we are able to reduce these emissions, well, then these vapors aren't just going to be lost, but they should be recovered as part of our process. And so that's going to be extra sales gas that we would have otherwise not had. So if I go back to my first flow sheet, this is the same Wellsite, but with a VRT. And what a VRT is it's basically just a tall, skinny separator that is going to introduce an intermediate pressure point between our heater treater and our atmospheric hydrocarbon tank. So our heater treater is at a pressure of 65 psig. If I double click on this vapor stream, I can see that value has been set. And the same thing for our hydrocarbon tank, except our hydrocarbon tank is at a pressure of 14.7 psia. And if we look at that in terms of psig, it's actually very close to 0. So effectively, we have a pressure of, or atmospheric pressure here in our hydrocarbon tank. But thanks to our VRT, which is held at a pressure of 3 psig, we're able to flash out all of the vapors that would have formed in the hydrocarbon tank out of the top of the VRT instead, because we get to lower the pressure before it actually gets to the tank. So therefore, we get any vapors that would form in the tank formed in the VRT, and we're able to recover that. Part of what we have to deal with now is if we want to recapture our VRT gas as well as our heater treater gas, then we're going to need to increase the pressure because our heater treater gas is at 120, our heater treater gas is at 65, pounds of pressure, and our VRT is at 3 pounds of pressure, whereas our pipeline gas is at 500 pounds of pressure. So if we would want to pipeline our heater treater and our VRT gas, we would need to increase the pressure of both of those. So what we've used here are cross flow sheet connectors, which let you send process stream information over from one flow sheet to another flow sheet. And in this case, these are going to send the heater treater gas and the VRT gas over to the compression station flow sheet. So if I click on that second flow sheet, we'll see the VRT gas comes in, gets compressed up, cooled, and we have a final amount of our recovered vapor. And we also have recovered vapor from our heater treater that gets combined, and both of these vapors are going to be compressed up to our pipeline pressure of 500 psig, and then mixed with our sales gas to be considered as pipeline gas. So looking at all of this, we know that there's going to be the cost associated with the recompression of the VRT gas and the recompression of the heater treater gas that is going to need to be weighed against the amount of vapor that we would be recovering. And so in order to actually see those economic effects or compare those economic effects, we use a tool in Promax called the scenario tool. The scenario tool is a tool in Promax that allows you to run case studies. Like in this case, we're going to be running an economic case study by having input variables in Excel plug into Promax, and then the results from Promax being sent back over to Excel. Now, this file already has an Excel workbook attached to it, but if you were starting a scenario tool from scratch, you would want to click on the Add Excel Workbook button in the top of the ribbon bar here, and that would embed an Excel workbook to your Promax file, and that Excel workbook would then be saved whenever you saved your Promax file, and it would also open and close whenever you opened and closed your Promax file. In this case, if I come down to where I see my Promax icon in my taskbar, I'll see two windows, one for my Promax simulation and one for the attached Excel file. So our Excel file already has a few things set up here. We have our table that's going to list our number of runs, the well flow rate as it decreases, and then the other variables that we're going to be measuring, such as what the compression duty of the VRT compressor is, how much gas we're recovering from our VRT, the energy required for our heater treater, the energy required to recompress our heater treater and VRT gas from 65 up to 500 psig, the total amount of extra pipeline gas we're getting, and then we're also measuring how much hydrocarbon liquid we're going to get as well. Because since our well flow rate is going to decline over time, this is setting the flow rate of both the gas and liquid into our system. So both of those are going to end up changing. Anything further to the right of column I is going to be calculations that are calculated using just Excel's formulas. If you look at the top left-hand corner here, we have a few different economic values to consider. We have the energy cost in cents per kilowatt hour, which we've converted over to kilowatt hours per day. Then we have our VRU rental fee, which is going to be in a monthly basis, but we've also reduced that to a price per day. We have the price of our natural gas, which is going to determine how much profit we're actually making from our recovered pipeline gas. And we have our oil price, which is the amount of profits we get from the liquid oil that comes out of our atmospheric hydrocarbon tank. So what we're going to be looking at is we're basically going to be looking at where we break even between the additional heat duty or the additional energy required to compress our VRT gas plus the rental cost, and when that breaks even with the amount of recovered VRT gas as our overall wellhead flow rate gets reduced. Now, the way to set up our table of inputs and outputs here is going to be by going to the Promax tab in the Excel ribbon bar, which is going to be the option all the way over to the right-hand side, and then clicking on the Scenario Tool button. Whenever you click on that, it's going to bring up a new window for the Scenario Tool, which is already pre-made here, but I'll go ahead and just create an example input and output variable, just so you can see how that's done. So I'm going to delete my current variable. And I'll also delete these two output variables, and we'll just walk through recreating them. So if we want to create an input variable in the scenario tool, what that means is we're going to give the scenario tool a list of numbers or inputs from Excel that are going to need to be plugged into Promax. So first, I'll click the Add Variable button in the Promax input area. And then in my window, I'm going to give my variable a name. So the only input we have here is the well flow rate. And then I need to reference what the cell address for the values that I want to take from Excel and plug into Promax are. And so those are going to be in cells B8 down to B25. So I'll click and drag from B8 to B25. And the very last thing I need to do is reference what Promax variable I'm using. That's going to be done by clicking on the Select Promax Object button in the bottom left-hand corner, and it's going to set this moniker box. So a moniker in Promax is effectively like is the equivalent to the file for a file path of a file that's on your computer. If you're looking for a file in your downloads, you'd have to go from your C drive all the way to your downloads folder and then double click on your file. If you're looking for the moniker of a variable in Promax, you have to start with the overall moniker tree, and navigate down to that variable. So in this case, we are looking for the well stream fluid flow rate. So I expand my flow sheets. My well stream fluid is going to be on my VRT flow sheet. So I expand VRT, and then I expand process streams. I expand my well stream fluid sheet or process stream. I expand the phases, total, properties, and I found my mass flow. And one thing to point out here is for input variables in the scenario tool, only variables that are bolded can be selected. This is because these are the variables that are open to being edited for this Promax object. So if you remember from when we looked at the well stream fluid stream, the temperature, pressure, mass flow, and the composition were specified. So that's why we can only select the temperature, pressure, and mass flow to receive values from Excel. So in this case, I'll go ahead and click on mass flow, and it will update my moniker. And so now, whenever I run my scenario tool, Excel is going to know that it needs to take my values from B8 to B25 and plug them in for the mass flow of my well stream fluid stream. So once this is all done, the last thing I need to do is double check my units in the top right-hand corner of this Edit Promax Input Variable window and make sure that they're the same as the units that I've entered for my numbers on Excel. And they're both in pounds per hour, so that's good to go. And I can click OK in the bottom right-hand corner. And that saves my input variable. So output variables in the scenario tool are variables that we're going to take from our Promax run whenever it inputs in the well flow rate, and take those from the Promax results and put them into our Excel table. So I already created the variables for the recovered VRT gas flow, the heater treater duty, the pipeline gas flow, and the hydrocarbon liquid flow. But I'm going to now create the variables for my VRT compression duty and my stage 1 and stage 2 compressor duties. So to add an output variable, it's very similar to adding an input variable, but we'll want to make sure we click on the Add Variable button in the bottom section of the scenario tool. We will once again give our variable a name. So this first one is going to be the VRT compression duty. We'll want to select our new cell address, which would be C8 to C25. However, our previous selection in Excel was from cells B8 to B25. And so we can take advantage of the cell selection adjustment interface in the bottom right-hand corner of this Edit Promax Output Variable window. And we can move our current selection over by 1 by clicking the directional arrows. So if I want to move over to the right one, I click the right-facing arrow, and it moves my cell address from C8 to C25. This may not seem too beneficial for a cell range of 17, but if you're doing a scenario tool that has 100 or 200 cases, which is definitely feasible, then that would save you a little bit of time selecting and highlighting. And now the last thing that we need to do is input in the moniker for our VRT compression duty. So how we found our moniker for our well flow rate, we're going to do the same thing to find the moniker in Promax for our VRT compression duty. So I'll click the Select Promax Object button in the bottom left-hand corner. This is going to open up my moniker tree where I was looking last, which was in the well stream fluids stream. And so I'll just collapse that, because what I'm going to be looking for is going to be on a different flow sheet. So I'll collapse the entire VRT flow sheet, and I'll expand the compressor station flow sheet. Here on the compressor station, I'm looking for a Q stream because I'm looking for the energy, which is represented in Q streams in Promax, whereas P streams are for things that actually have fluid flow. So I'll expand Q streams in this case, and PVRT corresponds to the energy required to compress our VRT vapor from 3 up to 65. And I will select the energy rate, and that will take care of the moniker. So the last thing that I need to do is to make sure my units are the same. Now the units that are being, or the units that we would like to record in our table is kW, because that's the units that we have for our pricing. Therefore, I want to change my units over from horsepower to our kilowatts. And now at this point, I can click OK. So that will take care of measuring the duty required to compress our VRT gas. Now we want to measure the stage 1 and stage 2 duties. So I'll go through the same process of adding an output variable by clicking Add Variable. I'll rename this variable stage 1 and stage 2 duty. I'm going to once again use the cell selection adjustment to move over my previous selection until I have cells F8 through F25 selected for recording the stage 1 and stage 2 duties. And the last thing I want to do is to select my Promax object. So I will click in the bottom left-hand corner for Select Promax Object. And now I'm going to be looking for my variable, which represents the stage 1 compression duty and the stage 2 compression duty. So in this case, we have 2 separate compressors with 2 separate energy streams that represent the total duty required for both stage 1 and stage 2. However, our output variable is only limited to selecting one variable at a time. We could go back to our Excel sheet and create two columns for stage 1 and stage 2, and then add the results together to get the entire stage 1 and stage 2 duty. But this flow sheet was created with that in mind. And what was done is we used a user created value to already total the energy rates of P1 and P2 together to represent the total compression duty for stage 1 and stage 2. And that was done using a user value and a user value set. So in Promax, a user value set is a group of user created variables that represent different variables and values that aren't typically in Promax. This could be something like ambient temperature, because ambient temperature isn't represented anywhere in Promax or isn't an exact input or output. You could create a user value for the ambient temperature and then set what the ambient temperature is. So if your ambient temperature is going to be 80 degrees Fahrenheit, you could set it. And then you could use that value for different applications like air cooling. In this case, we're just using a user value set to total our power from compressor 1 and compressor 2. And so if I expand my user value sets, I expand totals, I'll see the user value named stage 1 and stage 2 compressor power. I'll expand that, and then I'll expand properties, and I'll select the parameter, which is where the value is stored. Whenever I do that, now my moniker is going to show up, and I just double check my units. They're both in kilowatts, so that's good. And we're good to go there, and I can click OK. And since I was talking about that user value, I'm just going to go ahead and show you how that's set up on the Promax side of things before we run our scenario tool. So I'm going to go back to the Wellsite. To access your user value sets, you need to take a look at the project viewer. The project viewer can be accessed by clicking the top left button in the ribbon bar. And it's basically like a filing cabinet for Promax, so it contains it summarizes all the information in one place. So this has all of the results for your process streams, your blocks, your queue streams, any calculators that you have. All of those results can be found in the project viewer. So whenever you click the project viewer button, it opens up to where you last were. So I was looking at the heater treater gas last. But more importantly, it shows you a table of all of your variables here. And if we scroll down on this table, we'll find our user value sets. And in our user value sets, we have our totals user value set, which houses the user value for stage 1 and stage 2 compression power. Now, in that parameter box, instead of being a value that's directly inputted, you'll notice that it has a blue box. That blue box in Promax means that this variable is coming from some other source, whether or not that's an Excel sheet or a calculator. We can find out by right-clicking. And since we see that there's a show calculator option, we can click on show calculator, and it will open up the calculator that's creating the value. And what it will actually open up is our specifier for stage 1 and stage 2 compressor power. So in Promax, you have the ability to create specifiers that will allow you to basically set one variable in relation to already known variables, which in this case, we know the compression power of both P1 and P2. And we would like to make a new variable, or we created a user value that is the stage 1 and stage 2 compression power. So in order to set our user value relationship to our power of compressor 1 and the power of compressor 2, we created a specifier, and then we added those two variables, which is a similar process to adding variables in the scenario tool, where you would click add and then look through the moniker tree and add our variables, then give them a name. And so once we had both energy rates, we typed out P1 plus P2 in our equation box, and that performed the addition that totals up our compressor powers. Right, so now let's go ahead and go back to our Excel sheet. And now that everything is set up, we can simply run the scenario tool. If we look at the bottom right, it says going from run 1 to run 18, meaning it's going to start at our first row and go all the way down to our 18th row. You can customize that range if you'd only like to see one run. If you would only like to see the first run, we would change it from run 1 to 1, and therefore it would start on our first column and end at our first column. In this case, I'd like to see the results of everything, so I'll click run. And while that's running, we can go ahead and take a look at some of these economic columns here. And you might notice as well these colors that are flashing. If you see the yellow flash, that's an input variable. The blue flash is going to be output variables. And if you look over on the Promax side of things, the simulation does get new inputs and it will resolve. However, since the solve time here is very fast, about half a second, it might be hard to actually notice anything change color. So back to these economic columns, our VRT cost per day is going to be associated with the price of our rental fee plus the fee from the compression duty. Then our production sales from the VRT is going to be the price of our recovered VRT gas times the natural gas price. And so that brings our VRT profits per day to be the difference between how much it's costing us to operate our VRT and to own the VRT versus how much sales it's bringing us. And as we can see, the majority of that price actually comes from the rental fee of the VRT as opposed to the energy cost. Then in our next column, we have the total heater treater / VRT operating cost, which is going to add the rental fee for the VRT with the energy cost of the VRT compressor, the heater treater duty, as well as the stage 1 and stage 2 compressors together. And the total amount of money from our sales is going to be caused by or calculated using our pipeline gas flow times the natural gas price. And so the profits for running both the heater treater and the VRT is the difference between the total operating cost and our gas sales. And our total profits per day are also going to be our profits from our gas profits plus the profits of our barrels of oil that are produced times the oil price. And so if we take a look at the results so far, if you can imagine from the initial cost here, we would expect to see that as we lower our initial flow rate to maybe about half the value, our VRT production sales price is probably going to equal the same as our cost as an initial guess. And so whenever this well flow rate gets to maybe around 17,000, which is at the end, we should see that we're not going to be making a profit anymore. And at that point, it might be worth removing the VRT. The one thing that you would have to consider in that case is going to be how much of the vapors that you're not capturing in your VRT that will be treated as flashing emissions to your hydrocarbon tank, and whether or not you are permitted for that many emissions from that tank. So as we get closer to that 17,000, it very well does look like while our VRT cost per day started decreasing slightly because the bulk of that cost is actually from the rental fee, which is $208 per day, we end up losing profits, or our VRT ends up costing to actually operate instead of giving us an economic benefit whenever we hit about 18,000 pounds per hour, or at some point between 19,000 and 18,000 pounds per hour. So if we wanted to see exactly where, or if we wanted to extend our analysis to try to find out where that was actually happening, we could insert more cells into our table here and then update the scenario tool to account for those. So if I just insert a cell here, We'll insert a few more just so we can get better range. And then expand our runs down. So instead of going to 18,000 and 17,000, we'll decrease this by 100. And I'll just add a few more runs. I'll make sure these values are also carried down. Right, and then the last thing I need to do is just to adjust the scenario tool. So that can be done just by clicking the adjust cells option for both the Promax input and the Promax output areas. So here I'll go ahead and click adjust cells for my Promax inputs. And I'm going to set my number of runs equal to 26 here. Then click OK. And then I'm going to go to my Promax outputs and click adjust cells. And increase or set my number of runs to 26. And so now I have a total of 26 runs to account for my new additional runs here. And since I really only care about seeing the results from 17 down to 26, I'll change it to run from 17 to 26 and then click on the run button again. And we can see where exactly it is that we hit our break-even price. And so it looks like that's going to be somewhere around 18,400 pounds per hour as our initial flow rate into the system. Any more than or any less than that, and our VRT is going to be costing us to run. Of course, it's once again looking at that point, though, we're going to be looking at the amount of vapor that we would be emitting from our hydrocarbon flash tank. And comparing that to the cost of our profits per day. Because in general, we are still making profit due to the additional gas that's being recovered from our heater treater and from the barrels of oil. However, we're just losing some profit from operating our VRT. So if we take this case where we first become negative at 18,400 pounds, and we set that equal to our flow rate in our no VRT flow sheet, we can see what volume of vapor we would expect from our atmospheric hydrocarbon tank if we didn't recover anything, and that would be about 91.8 thousand standard cubic feet of vapor per day. And so at that point, now you're comparing your economics with that amount of emissions. So that about sums up the majority of the content that I wanted to talk about in this webinar. It was just mainly to be a little preview as to the capabilities of the scenario tool in interaction with Promax. So you can see here by changing those flow rates, and having our price information in Excel, we were able to see when exactly we would want to remove our VRT, or at least see the economic performance of our VRT and when we might consider removing it if the amount of emissions would be permissible. I would like to thank you for attending, and I hope to see you in a future class or webinar. And have a great rest of your day.